Example number 9, we have a two balanced three-phase loads are supplied by an 840 VRMS 60 Hz line. So load 1 is Y connected with 30 plus J40 ohms per phase. Load 2 is a three-phase motor drawing 48 kilowatts with a PF of 0.8 lagging. So assume ABC sequence. So first, calculate the total complex power of the combined load. Next, calculate the kVAR rating of the three delta connected capacitors connected in parallel with the load to raise the PF to unity. And lastly, the current drawn from the supply at unity PF. So first, let us write the given values. So we have 800 VRMS is our V line. And equals to 140 volts. We have a frequency of Hz. Now for load 1, we have Gy equal to 30 plus J40 ohms. Now for load 2, we are given the total three-phase power. We have 48 kilowatts. Then EF was to 0.8 and lagging. So assume positive sequence or the ABC sequence. So if we let VAB be our reference, we have VAB equals to 840 angle 0. So first is we need to calculate the total complex power of the combined load. In order to get the total complex power of the combined load, we can get the total complex power of load 1, and then the total complex power of load 2. So first, let's get the total complex power of load 1. So for load 1, we are given the per phase impedance. So we can use the equation for the total complex power. So we have the total complex power for load 1 equivalent to 3 times the magnitude of phase voltage paired all over the C phase, conjugate of the C phase. We have 3 times 840 over square root of 3 paired all over 30 plus 340 conjugate. So we have 8.467 plus a 11.29 kVA. Now for load 2, we are given the total field power and the PF. So remember the power triangle. This is PT, PT2. Since this is lagging, Q is positive, and this is for S. So here is the angle. Remember, PF is just equivalent to cosine of theta 2. So we can use tangent of theta 2 to solve for QT. So tangent of theta 2 equivalent to qt2 over t2. We have qt2 equivalent to 36 a bar. We have the total complex power for load 2, 48 plus J 36 kVA. So we have total complex power of the combined load is T1 plus 2 is equivalent to 56.467 plus J 47.29 kVA. So now, total complex power of the combined load. Now for the next question, calculate the kVAR rating of the three delta connected capacitors connected in parallel with the load to raise the PF to unity. If we have bar triangle of the total combined loads, 0.7 kilowatts, and we have 47.29 kVA. We have so at unity PF, unity PF or Q equals to 0. So the total kVAR for the delta connected capacitors should be equivalent to nearly 47.29 kVAR. So the Q for each capacitor is equivalent to QTC over T. So what if we were to get the value of the capacitance? The value of the capacitance of each capacitor. So remember, QC is equivalent to V squared over XC, where XC is equivalent to 1 over 2 pi FC. Now substituting this equation right here, this equation, then solve for C, we have equation QC over V squared 2 pi F. So QC right here is just UTC over 3. UTC over 3 all over. So what is V? What is the voltage? So if you look at the figure, the three capacitors are connected in delta. So the voltage across one capacitor is equivalent to the line voltage, which is 840. Paired, we have 2 pi and F is given as 60 hertz. We have so we take note that this is the magnitude QC. So C is equivalent to 59.26 microfarad. The last question is the current drawn from the supply at unit TPF. We have total power of 46.47 kilowatts at unity PF. PF is equal to 1. So using the equation, PT total real power is equal to square root of 3 PL IL sin of theta, where cosine of theta is just the PF. So IL is equivalent to 38.31 amperes.